Sun Intuitive Dynamic Glass is an innovative and intelligent glass product that can be used in both commercial and residential settings. Using heat from direct sunlight, Sun Intuitive technology tints clients' windows to automatically block heat and glare. On days of intense sunlight, when they might normally pull a shade or blind with traditional windows, Sun Intuitive glass gradually darkens, leaving their view to the outside unobstructed. Sun Intuitive Dynamic Glass allows clients to be comfortable behind the glass since it blocks up to 90% of the solar energy. As less solar energy enters the client's home, their AC does not have to work as hard, saving them energy and money in the process. Sun Intuitive technology reduces interior glare while maximizing daylight and preserving your client's view of the outdoors. Additionally, it eliminates those harmful UV rays, protecting your client's sustainable furniture and flooring. And because Sun Intuitive Glass always incorporates laminated glass, it reduces the outside noise and offers forced entry protection so your client's family are much safer. Easy installation makes Sun Intuitive Dynamic Glass a great choice for replacement or new construction windows. All right, well, welcome everybody to Introduction to Natural Hempcrete Construction Methods. This course is approved for 1 hour in continuing education units, AIA, HSW, GBCI, AIBD, Certified Green Professional, NARI Green, and Certified GreenHome Professional. I am going to be your moderator today. My name is Brett Little. I'm the Executive Director here at the GreenHome Institute. The GreenHome Institute does have a mission to make healthier and more sustainable choices in the renovation and construction of the places we live. I'm really excited to introduce you to the speaker today, Chris Magwood. He is obsessed with making the best, most energy efficient, carbon sequestering, beautiful, and inspiring buildings without wrecking the whole darn planet in the attempt. Chris is currently the Executive Director of the Endeavour Centre, a not-for-profit sustainable building school in Peterborough, Ontario. The school runs 2 full-time certificate programs, Sustainable New Construction and Sustainable Renovation, and hosts many hands-on workshops annually. Chris has authored numerous books on sustainable building, including The Essential Hempcrete Construction, Making Better Buildings, More Straw Bale Building, and he's co-editor of the Sustainable Building Essentials series from New Society Publishers, and is a past editor of The Last Straw Journal, an international quarterly of straw bale and natural building. I love that name. He has contributed articles to numerous publications on topics related to sustainable building and maintains a blog entitled Thoughts on Building. In 1998, he co-founded the Camel's Back Construction, and over 8 years helped to design or build more than 30 homes, commercial buildings, mostly with straw bales and often with renewable energy systems. Chris is an active speaker, workshop instructor in Canada and internationally. So with that, Chris, we're real excited to have you, and go ahead and take it away.
Okay, great. Well, thanks, and thanks to everybody for showing up. This is my my first time presenting in this forum, so I hope it all goes smoothly, and I really appreciate you you signing on and listening into this. So I guess we'll start right away with what it is that attracted me to hempcrete and attracts a lot of people to hempcrete, and that is that the hemp portion of the hempcrete is an annually renewable plant-based material that has quite a few desirable thermal and moisture properties, and can have a reasonable cost as an insulation material, and probably most importantly, a very straightforward construction process, in that you'll see as we go through, unlike a lot of other sort of natural alternative building systems, hempcrete aligns really well with conventional frame construction, in that it's an infill insulation that relies on sort of standard frame walls in its construction. So it's one of the few alternatives that sort of melds really nicely with conventional framing. Anybody who has probably spent any time at all looking into hempcrete, especially in the online world, you may get the impression that you know, if we all just switched to hempcrete tomorrow, the world would be saved and children would be happy, and you know, everything would be Great. It's not really that miracle material. There are a lot of really good things about it, but as with all materials, there are also limitations and drawbacks. We'll talk a little bit about the carbon neutrality of hempcrete. It has a lot of great properties if you're looking to build a low carbon building, but sometimes the claims around its carbon neutrality can be a little bit overstated. And a lot of people seem to mistake, I guess because the word crete is in hempcrete, that somehow it's a replacement for concrete, and it's not. It's not a structural material. You can formulate it in a way that it's kind of semi-structural, and we'll look at some of those formulations, but it's certainly not, you're not going to build a skyscraper out of it. You're not going to build structural columns out of it or anything like that. So it is largely an insulation material. So the essential components of hempcrete is the hemp itself, and the hemp is the core of the hemp plant. So the fiber, which is kind of the desirable part of the hemp plant for most growers, is stripped and removed and sold, and then the kind of woody core of the plant is what's left over, and that's what we want for hempcrete. And you can see a little mound of it there in the middle of the picture. And then that's mixed with a lime-based binder. So that's a calcium carbonate, the same kind of lime that you would use in sort of mortaring or plaster work, and water. And you mix those three things together, and you get an insulation that's largely used as a wall insulation, but we'll look at some other applications for it as well. So we'll dive a little deeper into the material side of things. The lime binder itself, it needs to be lime that has a hydraulic set. So a lot of the plastering and mortaring limes cure by exposure to air. They recarbonize, and so when you use them in a thick application like hempcrete, where you might have a 10, 12, 14, even 16-inch deep wall, the middle portion of that lime, the stuff in the center of the wall, will not sort of be exposed to enough air to actually cure, so only the outside edges will. So hydraulic limes, as the name implies, sort of have a hydraulic set, which means that they, when mixed with water, the interaction with water chemically provides a portion of the set, and then they continue to carbonize over time. Where hempcrete really got going was in Europe, in France and England mostly, and their natural hydraulic lime is a fairly common building material. It's something that's widely available, manufactured in both countries, and you can see a couple of the products there. The Saint-Astier is from France, and the Tradical is from England. And so the hempcrete builders in that part of the world tend to go for those prepackaged hydraulic lime products. You can do that here. There are some importers of them, but they tend to be extremely expensive. And one of the things that, if you've heard that hempcrete can be really expensive, that's one of the reasons why is, importing a product that's already a bit of a premium product in Europe. By the time you bring it to North America, pay for the shipping, and pay for distribution in really small quantities, the price gets really high. What we tend to do is use more widely available North American produced lime. So there's a picture of a gray Mont bag there, but whatever sort of type N hydrated lime you would normally use for mortar work or plaster work. And then we mix it with a pozzolan, which is a material that, when added to lime, gives it a hydraulic set. And metakaolin is the most common pozzolan that you can get your hands on here. So that's a kaolin clay that's been fired at a really high temperature. And we'll look at the proportions of how you mix those things a bit later, but essentially most of the hempcrete work that we've done here in North America is using some form of that kind of mix. So that's the lime portion, that's the binder. So that's what we're going to use to coat each of the little pieces of hemp, and that gives it protection and also allows them to sort of stick together. And that's how we're going to make this material bind in a way that it keeps its shape in the wall or attic or floor or wherever we're using it. So the other component, the hurd or the shiv, as it's sometimes called in Europe, like I said, it's the core of the hemp plant. So the seed has been removed, if that's why it's being grown. The fiber has been removed, and we're left with the sort of pithy part from the middle of the plant. And what makes hemp interesting, some people, when they see that photo, they think, well, I could just do this with wood chips or, other kind of chipped cellulose materials. And what sort of makes hemp interesting in this application is that it's a very lightweight core. So it's an extremely porous, hollow. There's sort of more airspace than there is cellulose in there, and so it's an extremely lightweight plant material, and that's what makes it so desirable. Because of its lack of availability, especially in the U.S., we're also looking at other plants that could provide the same qualities. For instance, sunflower stalks, Jerusalem artichoke stalks have a very similar density, and we're actually just starting to do some experiments here to see if those would work in the same context. But we know that the hemp works. It's got a good long history of proving that it works, and so that's what the focus of this talk will be. The hurd, ideally we want sort of pieces between 1/2 to 1 inch in length, dust-free. The fiber has been stripped. It's there's inevitably some fiber in there with the hemp, but sometimes there can be a little bit too much. It makes it too dense. So a nice clean version of hemp. You can get hemp from suppliers who prepare it specifically to be used in hempcrete, and that's really the ideal way to go. Having it sort of doing your own chipping and shredding, or having like a local farmer do it, that can definitely work, but there will be a bunch of extra effort involved in removing the fines and the particulate and the dust, so that you get the nice bigger pieces that contribute to a lightweight mix. So of all the properties of hempcrete, I think its moisture handling capabilities are what draw me to the material and why we incorporate it into our buildings. We work with a lot of other plant-based materials at Endeavour Centre, including straw bale, straw clay. There are all kinds of bat insulations, conventional cellulose insulation. So all of these sort of plant cellulose-based materials have quite similar properties. What makes the hempcrete unique is that because it's being coated in lime, lime is an antimicrobial, an antifungal, and so should the wall get saturated with water, a plumbing leak, a roof leak, a flood, those sorts of things, hempcrete is extremely resilient in those cases. It keeps its shape because once the lime has gone back to being limestone, once it's hardened up, the material is very solid, and although you have a lot of cellulose material in the wall, because it's all wrapped in this lime mixture, it's incredibly resilient to wetting and drying, and makes it a plant material that's quite attractive to use in lots of different climates. It's as good in sort of hot, humid climates as it is in sort of cold, rainy climates. And the lightweight structure of the hemp plant means that it has a huge amount of pore space in each piece of hemp chip, and that gives it a lot of moisture storage capability too. So when you're looking at moisture migrating through a wall, the amount of moisture that the hemp material itself can take on before there's anything close to condensation is much greater with hemp than any other material. So the moisture handling capabilities are really, for me, the main attraction to using this material. And like Brett said, feel free to type questions in as I go, and I can stop and discuss things in more detail if that's appropriate. And if not,
Chris, I didn't know if you're going to get to this yet, so I didn't bring it up. But are you going to be talking about sort of the dry out period and risk of closing up walls that are still wet?
Yeah. Yeah, we'll get to that a bit later, sort of looking at the installation side of things. And
as far as, do you have any recommendations that we can discuss later about suppliers of SHIV around the U.S.?
Yeah, I'll look at supply towards the end as well. Yeah.
Okay, great. All right, we'll get to those later then. Thanks, everyone.
Okay, so the thermal performance of hempcrete, again, this is something that you'll often see kind of overstated on the internet. People like to ascribe this material sometimes some kind of magical properties. And the truth of the matter is, if you do actual, ASTM style testing on this, you get a steady state R value of between sort of 1.5 to 2 per inch. So it's not the greatest insulator in the world. You can see there that the kind of mix that we use in the wall, we're getting R16 out of an 8-inch wall, 24 out of a 12-inch wall, or 32 out of a 16-inch wall. So it's while it's certainly possible to sort of meet or surpass code, the exact properties that made it so ideal in the previous slide, the addition of the lime, which is what gives it its great moisture handling capabilities, the density that the lime adds is sort of what robs it of its insulation value. And so you can see there in this chart the mixed densities on the left-hand side. As you make the material more dense, and we'll look at how you do that. You can sort of choose to make a lighter or a more dense mix, but as the mix gets denser, obviously the R value goes down, and then we'll there are places where you might want that, say under a slab, you might want that material to be more dense to be able to handle a load. In an attic where you don't even care if it keeps its own shape, you can go for a really lightweight mix. So, like I mentioned at the beginning, hempcrete is not a replacement for concrete. However, you can formulate mixes that have some structural properties. The photograph there shows some sub-slab hempcrete insulation going down. So it's got, that mix has enough strength to be able to handle the distributed loads of that slab, no problem. But like I said in the previous slide, as you make those mixes more dense, the insulation value also goes down. So you're kind of always looking for a balance of, what's the least amount of structure you're requiring from this insulation, which will get you your best R value. Fire properties, it has not been tested to any North American standards yet. We have been able to get our buildings past our very stringent code here in Ontario, Canada, by showing the sort of equivalency of European fire tests. And there are quite a number of those, all done to, obviously, to European standards. They're not quite the same as ASTM, but we've been able to, show that to building departments, and when they see that, it's easily passed 75-minute European burn tests on a number of occasions in a number of countries, all to the same testing standards. But that's usually been fine for us to get it approved here. So the environmental benefits, again, if you're researching hempcrete online, this is the kind of stuff that you'll hear about. And some of it is true, and some of it is sometimes a little bit exaggerated, but the hemp production is low intensity and relatively low impact. And by that, what people mean is quite often farmers are able to grow it with either fewer or absolutely no pesticides or herbicides. So it is a weed, and it grows, it jumps up quickly in the spring, and it grows fast, so it tends to choke out competitors. And there aren't a lot of insects or other pests that tend to disturb it. So, in comparison to some other crops or lots of other crops, there's often a lot less input into the hemp plant than other ag crops. The hurd, that inner portion of the plant that we're interested in using for hempcrete, is also secondary to the seed or fiber production. So, if you're sort of calculating the impacts of farming it, we're actually using the byproduct. So, it's a way of making sure that you can use the whole plant and not just the seed or the fiber. Its production doesn't sort of cause any byproducts or industrial waste. The carbon sequestration, I think I've got a slide that sort of formulates that a bit later on, but as with any plant-based material, about 50% of the weight of your hemp hurd is literally carbon, and so that carbon that's been, pulled, the CO2 is pulled out of the atmosphere and sort of added to the makeup of the plant itself. And so if we're kind of, the plant's taking that out of the atmosphere and we're bundling it up and putting it in a wall for, a good long time, 50, 100, 200 years, then that's carbon that's been, removed from the atmospheric cycle. So it sort of has a positive effect that way in terms of carbon and climate change. There's little to no on-site waste or offcuts. It's a loose mix material that you're sort of packing into the area that you want to insulate, and so you just make as much as you need, and if there's any left over, it can just be composted. There's no need for it to go to landfill. And it does have really good indoor air quality properties. The combination of the porosity of the plant and the antifungal nature of the lime means it's really clean. It's not off-gassing anything, and it's not sort of emitting any toxins into your building or introducing anything that's anything less than food grade. So those are all, great environmental benefits, but there are some caveats to that, and this is the stuff that sometimes the online proponents of hempcrete don't like to talk about, and I don't think there are reasons to not use it, but they are things to keep in mind, and that is that the production of the lime is both energy and carbon intensive. You're harvesting limestone, you're burning it at a high temperature, and you're creating a bunch of carbon emissions and other emissions in that burning process. Advocates of hempcrete will sort of say, well, the lime actually recarbonizes, and that's true. As it turns back into limestone, that process is reversed, and the CO2 gets drawn back into the lime. But that process is not 100%, depending on how thick the wall is. Tests show it's sort of reabsorbing somewhere between like maybe 25 and 75% of the CO2, and it doesn't at all address the CO2 that was emitted from the fuel that was used to burn that rock. So you'll see later on in the slideshow, we'll actually quantify this, and overall the material is a net carbon sequesterer, but unlike other plant materials, if you're using cellulose or straw or cork or bamboo or any of those things, because they don't have the lime, their sequestration levels are actually higher. Another caveat is that large-scale hemp production does typically use high quantities of fertilizer, so that obviously has environmental implications. The plant grows anywhere from sort of 8 to 12 feet tall in a season, and clearly takes a lot of takes a lot of nutrients out of the soil in order to be able to do that. And unless you're finding organically grown hemp, which is, I have not been able to source anything like that in North America, there is that fertilizer issue. And also, as I was talking about the lime earlier on, if you want to use natural hydraulic lime instead of formulating your own, that only comes from European sources, and clearly there's an environmental impact to bringing that from Europe.
Chris, you had mentioned, and I was going to bring it up on the organic side. Is one of the barriers just simply because of all the fertilizer needed? They haven't been able to find organic approved, you know what I mean, fertilizers to certify the hemp. You think that's kind of the issue?
Well, I think a big part of it is right now that the main use for hemp is the fiber, and so it's not really a food product, and so people aren't that concerned. The end users of the fiber aren't that concerned about organic growth, and so there's really no drive to there's nothing in it for the farmer to grow an organic hemp. So I think that's a big part of it. But it would also take some pretty healthy crop rotation to to be able to do hemp organically. I mean, that said, it's taking a similar level of fertilizer to say corn or any other kind of tall plant that has to feed a lot of growth in one season.
I know some green builders look at sustainable manufacturing, so I mean, that could be one of the.
It could be. I think
yeah.
when you look at it, even though there is some fertilizer use on the hemp plants, if you were to sort of put that into context versus say, melting glass to make fiberglass, or the whole cycle of production that gets you from crude oil to say a foam insulation.
You're already way ahead.
Yeah, exactly. The impact of the fertilizer in the hemp is a pretty small drop in the bucket in comparison to sort of other insulation types.
Okay. We have some questions here about code and vapor barriers. I don't know if you plan to cover that a little bit more, or if you want.
Yeah, I'm gonna talk quite a bit about code towards the end, because clearly, anything that we're building with like that isn't directly recognized in codes, that is a big issue. So I will sort of directly address that a bit later. So right now, this next chart that we're looking at, this is sort of looking at the carbon sequestration. So, you can see a range of different insulation options down the left-hand side of the chart there, and they range, the top few are all plant-based materials, and you can see that they end up in the negative range. So in other words, they are sequestering carbon. And hemp being the highest sequester there, and the reason it turns out higher is because it's more dense. So you're actually packing more of it into the wall. So it ends up at the high end. But you can see as we move down through like straw bales, cork, cellulose, denim, the numbers start to get higher, and then you sort of pop into the positive side. So you can see that the foam insulation that's there is quite high in embodied carbon. So all of these plant-based materials, Hempcrete included, kind of give us the potential to build a building that either has a zero or even a negative carbon footprint. And I think that's one of the main attractions for us in our practice is we spend in the building industry a lot of time thinking about energy efficiency as a way to drive down emissions and address global warming, but you can also do it with your building materials right up front, which has a pretty significant impact. Okay, so uses for Hempcrete in the building. You're looking at a whole bunch of them here. So it can be used as ceiling and roof insulation, wall insulation, under slab insulation. We also use it as the insulation around our windows, between the window and the rough framing. And in this particular building, it's also, that's integral with the window sills and the trim. So all of that is actually built out with hempcrete. There's a bench top, and you can do sort of other decorative things with it. The hemp also can be incorporated into plasters. So, you know, in that one building we're looking at, there's hemp used in all those different areas. And so we'll kind of now look at the specifics of how each of those works. So as wall insulation, which is, you know, by far and away its most common use, the most typical scenario is it's installed into a frame wall, and quite often a double stud wall, which allows the thickness to be tailored to the amount of insulation you want. So up here in our climate in Ontario, Canada, we're doing hempcrete walls that are anywhere between sort of 12 and 16 inches thick, and so the double stud walls are spaced that far apart. And then we're using a fairly lightweight mix for those walls, somewhere in the neighborhood of 200 to 275 kilograms per cubic meter, and that's, you know, just enough density to have the material turn into a solid in the wall, so it maintains its own shape and is rigid, but as light as possible to get the best R value. And also, I mentioned packing it in around the windows. So we do that in place of, you know, spray foam. We pack it in around the windows, and you can either just use it as the window insulation, but what we've found works really well is to kind of put it in the framing gap around the window, but then actually build it all the way out onto the surface of the wall and make an integral trim. And that's a great way to quite quickly get a nice airtight insulated window system and a trim detail all at once. And you can continue that to the inside and the outside, or just one or the other, or like I said, you could just use the hempcrete between the windows. It's not the most common use for hempcrete. In our particular building practice, we're always trying to move towards the most natural materials possible. So, you know, to be able to replace something like spray foam in this scenario with the hempcrete, it suits our goals really well. So for roof insulation, it's a very lightweight mix, and typically we're not sort of tamping this material at all. So we're just sort of mixing it and pouring it loose into those cavities. So that gives us our best R value, and because it's on either the slope or the flat surface, it doesn't need any tamping or any added density to keep it in place there. And then I mentioned before the sub-slab mix. You know, you can see we're making that a bit denser. So we're doing that both by adding more lime to the mix, but also doing a bit more tamping, and that gets us to the point where we can handle the loads of a slab floor on top of it. And a few less common uses, but also quite valid and interesting ones. Hempcrete makes a great masonry material if you're doing cordwood construction, because what it means is that rather than having to do a masonry skin on the inside and the outside and pour loose insulation into the middle, you can just do the full width with hempcrete. So you get a much more airtight cordwood construction and a much more insulative one. And so we have used that a few times. Some decorative interior elements. If you get a chance to work with the material, it's got a lot of really unique properties. It's extremely sculptable. It just kind of like you stick it together, and even though it's lightweight, it holds its shape incredibly well. So it allows you to do all kinds of sculptural things with it. And in one case, you can see on the bottom right there, we actually used it as a perimeter beam foundation. So that's a grade-based perimeter beam that the walls then sit on top of. I'm seeing a question about documentation on shear value of hempcrete because no sheathing on the studs. There is a bunch of testing done on that. You can find those things in the Essential Hempcrete book. If you know your building official isn't open to looking at those kinds of tests, you can just put sheathing on those studs too. But it does provide a huge amount of shear strength to the studs, and depending on how you finish out the wall, we'll look at finishes. But if you're plastering the wall, which is a really common finish, that plaster is also adding a bunch of shear strength to that wall too. So often we're looking at it as a whole system. So mixing the material. The ideal machine is the one on the right, a vertical shaft mortar mixer. It does a great job of turning out large batches of hempcrete, but those machines can be kind of hard to find and expensive when you do find them. So we do most of our mixing in a conventional sort of horizontal shaft mortar mixer, like the one you can see on the left there, sort of turning out 6 to 10 cubic feet of material at a time, depending on the size of your mortar mixer. The pictures on the bottom left are just examples of larger, sort of more industrial-sized machines. The Europeans are, very far ahead of us in terms of their use of hempcrete, and so, there's been more investment into, specific equipment for turning out large batches of hempcrete, but at this point, we can quite cost-effectively do it just in a conventional mortar mixer. Okay, so this is the sort of the basic wall mix ratio that you can see here. I apologize, I'm a Canadian, so all of my units are metric, but you can basically just convert these to pounds. It's a ratio, so it works out just fine. But basically, it's a kilogram of hemp to a kilogram and a half of the lime binder, and somewhere in the neighborhood of a kilogram and a half of water, or that could be converted to pounds, 1 for 1. And for us, our lime binder is half hydrated lime and half metakalum, as I was explaining earlier. One of the things that we do, and this picture on the top left is sort of alluding to that, is because for the wall mixes, the installation involves tamping to sort of pack the material into the wall. If we're aiming for a certain sort of, pound per cubic foot ratio of the material, what we do is make a bunch of 1 cubic foot boxes and have, sort of work with the crew and watch them actually tamp their box and weigh out those boxes, and that really gets everybody on board with, understanding, okay, if this is what we're aiming for as a density in the wall, once you figure out how to get your box, your 1 cubic foot box to that weight, then you have a pretty good idea how to translate that into getting the right density on the job site. This is a look at now those mix ratios for different densities. So that 1 to 1.5 ratio is for a sort of mid-density wall mix. So you can see the very light ones, it's sort of 1 hemp to 1 binder, and as you move up, you're sort of just increasing the amount of lime binder, and so that the coating basically on each piece of hemp gets a little thicker. You have a bit more of that structural material and a bit less of the hemp material proportionally. So obviously, as you move into the more dense mixes, the cost of the lime goes up for the amount of area or cubic volume that you're filling. And you can see also that the amount of tamping required is kind of noted there. So when we're doing the lightweight roof mixes, we're not tamping at all. We're just sort of pouring it in loose. As we move into the sort of mid-range ones, we're tamping is probably too severe a word. We're sort of pressing that material in, and if we're trying to get the high density, the sub-slab stuff, we're actually, you know, compacting it to some degree. So now the binders, like I was saying earlier, that the hydrated lime is a sort of the starting point for most of these. If you are going to use the European natural hydraulic lime, so that's in the left column, if you see NHL, that's natural hydraulic lime. That would be the stuff that you'd be importing from either France or Portugal. Quite often, people will sort of cut that with North American hydrated lime, so you can see, you know, proportions, you know, starting in the 50-50, half of each ratio, and sort of moving up and down from there. The hydrated lime and metakaolin, that's our go-to mix. And like I said, metakaolin is a fired kaolin clay. Most masonry supply stores will either carry or be able to get you a version of metakaolin. It's also used as a admixture in cement mixes as well. So that's something that you should be able to get your hands on. And mixing it 50-50 by weight or volume is sort of our default. There's the ability to vary from that kind of 10% in either direction, but it's just so easy to measure it out at 50-50 that that's what we go with. Some builders have experimented with using magnesium cement to provide their hydraulic set. I haven't done that myself. I'm really keen to. It's a very fast set, and so that could speed up some of the sort of dry time issues. But getting my hands on the magnesium cement, just none of our local suppliers here carry it, so I haven't gone down that path. And you can use Portland cement. It will kind of take the lime and give it that hydraulic set as well. But the Portland cement makes the mix much denser. So even though it looks like you're adding the same amount of powder, so when we have used Portland cement, we've done 80% lime, 20% Portland cement. And even though it seems like, you know, that shouldn't make a big difference, the mixture turns out noticeably denser for the same amount of binder. So we haven't gone that way. And the Portland cement also, it doesn't handle, not that it's disturbed by moisture, but it's not as absorbent or porous as any of the lime mixes. So it kind of reduces some of the moisture handling capabilities of the wall too. I'm seeing the question about hempcrete being used as an insulation on the warm side of a concrete foundation wall. It has. We've done that ourselves, and a few other builders have. It hasn't been really thoroughly tested. We just did it on a couple of the large concrete block walls at our shop, and we've been monitoring it now for 2 winters, and we're not seeing any condensation between the hempcrete and the concrete. We didn't install a vapor barrier of any kind just because we wanted to sort of see what would happen in the worst case scenario. So that gives me, you know, a lot of confidence to say, you know, that I would do that, and it is something that that I would now, you know, tackle on a renovation where I'm doing that. But it's, you know, there's not a ton of data on it. You know, it's basically going on a few anecdotal installations.
Chris, was that have you put like moisture sensors in there, or just did vapor test?
So,
okay.
No, so we've been doing moisture sensors between like, you know, squeezed up between the hempcrete and the concrete, and yeah, there hasn't been any issues. You know, even you know, it gets pretty cold where we are here, so we've got a pretty strong vapor drive, and you know, that's watching that over the last 2 seasons has given me a lot of confidence in it. But I wouldn't just straight out say yes, you could do that anytime in any situation. But I think it's definitely one of the things that it could be used for. And I think, you know, in that way, it's one of the natural materials, you know, when I said earlier that the moisture handling properties of hempcrete is what really attracts me to it. The ability to use it in those places, you know, old rubble foundations, concrete foundations, the spaces between floor joist ends, you know, in older buildings and stuff like that, where you just would never risk, you know, cellulose or straw or an unprotected cellulose material. The hempcrete does really well in those places. So a big part of using hempcrete in walls is it's basically it's a formwork system. However, for anybody who's used to concrete formwork, it's nothing like that. The material is extremely lightweight, and so our system that we sort of rely on is the one in the top left there. So it's just 1/2 inch ply screwed to the studs. We use roofing screws so that we're using like a hex head that sits above the formwork as we drive it in, so we don't lose our screws and have the heads fill up with hempcrete as we go. And the material goes in between the formwork. It's tamped lightly, and you don't have to form the whole wall. You can literally slip form like within 30 seconds of, you know, tamping in the last lift of hempcrete. You can just undo the form and slide it up and go again. So it's not, you don't have to do continuous formwork, and you don't have to leave the forms up for any length of time at all. The bottom left is something we've also done. So there we do put a permanent form. It can be on the inside or the outside of any sort of permeable sheeting material. So that's cement bonded wood wool in the photo you're looking at there. It could be wood fiberboard, anything that has a good permeability that'll let that moisture dry out through the material. So you can't use plywood or OSB as a permanent form. So you can use them as temporary forms that you slide up and take off. But if you left it on, the moisture from the mix would not leave at a great enough rate, and the dry times would be really, really long. The picture on the bottom right, and I'm not sure why they do this, but all the European builders tend to go with a single stud wall, and they kind of attach their formwork from both sides with spacers, and then as you take the formwork out, you pull the spacer, and then you kind of stuff a bunch of hempcrete into the hole that was left behind by the spacer. Because that's how I saw it done the very first time we did it, that's how we did it, and I couldn't believe what a pain it was to do it that way, and that's why we switched to the double stud system. But that you can sort of bury the frame entirely in the material if you want. So like I said, it's, most of what's going on with hempcrete now is in UK and Europe, and they've gone from the kind of small scale applications that we're doing residentially here to tackling much larger projects. And some of the ways they're doing that are with spray applications. So they're only forming one side of the wall, and you can see on the top left there, spraying it up against the wall, and then much like with sort of wet blown cellulose, kind of screeding it off to the frame, and they then they don't have to sort of pour and pack like we're doing. And they're also just in some cases using much bigger mixing material and much bigger placing systems. So you can see it going in with a bucket on the zoom boom there. So they're able to kind of fill way more cubic feet than you can with humans and wheelbarrows. And I think most kind of promising of all are the sort of prefab panels and blocks that are starting to be developed, where all the pouring, forming, and drying is happening off-site, and the hempcrete companies are sort of supplying a builder or an owner or a contractor with a hempcrete unit where the person on-site is not responsible for the mixing or the forming or waiting for the drying to happen. And I think this is where we'll see it really start to reach into the market when these types of developments start happening here in North America. Finishes on hempcrete. A lime plaster applied right to the surface of the hempcrete is by far the most common approach. You get a really great bond between the plaster and the hempcrete surface. They work really well. The lime creates a continuous air barrier and moisture control layer that's permeable on both sides. So that's a really common approach. However, you can treat it like any insulation. So you could just wrap the building in, say, a house wrap, and then fur it out and do a rain screen siding of any kind. You can see a vertical wood siding in that one photo, but people have done, brick, stone, wood products of all kinds, cement fiberboard products. It doesn't really matter. You can just kind of treat it like an insulation. Seeing the question about the double stud stress cracks in the render. Not really. We mesh over the studs and have not found it to be an issue. It just the mesh covers the stud and bridges over onto the hempcrete about an inch in either direction, and that's been sufficient to control that kind of cracking in our climate. So material costs, obviously this is something everybody wants to know. Now these costs, it's tough to pin down a cost for hempcrete because it's very dependent on where you are and how accessible these materials are to you. And I would say, definitely right now this is the thing that makes hempcrete less than viable, especially in the U.S. Here in Canada, there are Canadian growers, and we can access material from those Canadian growers. But if you're in the U.S., it's not being grown in your country, and so you're looking at either Canadian or European, or in some cases Chinese imports. And it's unfortunate because right now it takes a material that should be incredibly cheap and makes it more expensive than it needs to be. But I think should the hemp market develop, there are some U.S. states now handing out permits for experimental hemp farming. As that expands, it will definitely the price will drop quickly. But right now, sourcing so these prices are actually all in Canadian dollars. So there may be some differences if you're buying material from Canada. These prices may actually be lower, but comparatively, if we can get our hemp and lime and metakaolin all relatively locally, we are at about $3 a cubic foot for materials. The bottom price of $10 a cubic foot, that's if I'm importing European hemp, importing European binder, that would be my price here. So you can see that's a huge variation, and the final price on your site will kind of depend greatly on where you're getting those materials from, how many hands they're passing through on their way to you, and how people are marking that up. And you can see how that compares out to some other insulation materials. So it's definitely more expensive than our typical kind of batt insulation. It's a little cheaper per cubic foot than the foam insulations, but obviously you need more of it. So at this point, it's pretty much the one of the most expensive insulation materials that we work with, and we'll choose it for a whole bunch of other reasons. Its moisture handling properties, its structural capabilities. There's a lot of great things about it. Its carbon sequestration, all that kind of stuff. But right now, it is definitely costing more than other insulation.
Chris, since this is sort of a, even if it were purely accessible to the same degree that the straw clay and straw bale are, won't you think it'd be more fair to compare it to those than some of these other ones, just because you sort of get a type of client who's going after a certain natural building material?
It would be.
I mean?
The problem there is it's very hard to compare, straw bale costs can have the same kind of variability. So, I looked at doing that in this chart and it just ended up being, the same kind of the span of possibility is so wide that it, there isn't a fixed cost for any of those ones either.
Absolutely. So almost you could say on the cost side of things, it's probably right there with it, right? I mean,
I think, straw bale is definitely cheaper because what's adding, the bulk of the cost to the hempcrete is the lime. It's a material that's not in any of the other sort of natural wall systems, and it's an expensive material. So you're buying this, additional moisture handling capability and durability by putting the lime in, but it's costing you in added density, so less R value per inch and extra cost. So even compared to the other natural materials, it's the most expensive one. But it's because you're paying for this extra ingredient that adds some desirable properties in some cases. Okay, I'm noticing that we're getting on in time, so I'm going to pass through this slide. This one is looking at sort of, what some of the major hurdles and issues are for this material in North America. And by far the biggest one is that the sources for hemp and lime, it's a tiny little market right now. Essentially, there are 2 Canadian producers doing it at any scale and 0 American producers. So that means it's definitely not widely available. And, much the same as what happened in Europe, it certainly was not hempcrete construction that drove the hemp market. The hemp market developed for both seed and fiber, and then the producers had all this herd left over, and so it made it, it opened up the market because now there was this waste material that everybody could get their hands on for a good price. And I would imagine that the same thing sooner or later is going to happen here, but until it does, those economies of scale just aren't there. The higher labor inputs for the formwork and the mixing and the placing, I'm not actually sure that's an issue. We've done lots of conventional work and other natural building materials and hempcrete, and really the labor per square foot of wall is very similar, but definitely, if we had more industrial mixing technology and sort of permeable wallboard options, it would reduce that further. And so the last one is something we haven't touched on yet, but it's definitely an issue. So the drying time, now this is something, clearly the drying time is highly variable, both on the mix side. So, controlling the mix so that the right amount of water is going in is hugely important. So that's why in the formulations that I gave you earlier, there's an actual weight, or you can convert that weight to volume of water. And really what you want to do is use as little water in that mix as possible. But if you super saturate the mix, the dry time goes up. So what we've been finding is between 1 to 4 weeks of drying time before closing in the walls, and that if our mix was done right, that variability is really based on weather. So if we're doing it in the shoulder seasons where it might be both cold and damp, we'll see the longer drying times. If it's happening, on nice dry summer days, the drying happens quickly. So, I mean, really, that's a a matter of trying it out in your climate and seeing how long it takes. But it is something, if you are interested in hempcrete construction, keeping that in mind and knowing what that length of time is going to be, you'll have to figure that into your schedule. So, what we do on a hempcrete building is get the framing up, get the hempcrete in right away, and then, sort of schedule, say, then, finishing up the roof, getting static insulation in, maybe even finishing out the ceiling or something like that, maybe even addressing the floors, and by the time we've done that, we're good to come back to the walls. So yeah, I think for hempcrete to have a really, a real impact on the market, various forms of prefabricating it will be important. And I'm really excited by the block system on the left there. It's called Just Biofiber. They're in Alberta, Canada, and they're a startup. So this is going to be their first year of production. We're going to be hopefully using some of their blocks on a project we're doing. And I think the brilliant part about their system is those embedded 2x2s are also the structure. So that's not a block that you have to frame into your wall. It's stacked, and you're getting the structure and insulation all in one. The block is dry, and so I kind of see that type of approach as the way forward for hempcrete, much more so than on-site mixing and forming. And precast wall systems like the HemBuild one that's in England right now. So I think, always for owner builders and people who are sort of looking to put their own labor into the building, obviously, the site mixed, site tamped kind of version is entirely appropriate. And it can even be done, on a commercial basis. But I think, these sort of prefab systems are really the way forward for moving this material more into the mainstream. These are some of the resources that I would suggest. The Essential Hempcrete Construction is the book I wrote, and lots of the charts and tables from this presentation are in there. So that book is my attempt to be as explicit as possible. The Hempcrete book, actually, all the other three books are from the UK. The Hempcrete book is a good sort of introduction. There's no recipes or formulas or anything in that one, but it's a good sort of overall look. And the building with hemp and hemp lime construction are both pretty specific to British, UK building methodologies, but there is a lot of good information in it as well. And it's just a look at some of the finished hempcrete buildings that we've done here. The nice thing about hempcrete as an insulation system, and especially one that you can twin with either traditional stud framing or timber framing, the buildings don't have to look any particular way. They can be plastered on the exterior, but they can also be sided, really it's not something that has to call attention to itself in the building. But if that's one of the reasons you're doing it, then you certainly can draw attention to it. But it's been a really sort of great resilience, in particular, is what I like about it, and natural building material for us in our practice. So I think I must be pretty close to the hour here. So I'm happy to take any questions that remain from the presentation.
Yeah, great. Chris, we got some time to stick around for questions if you got a little bit.
Okay. I see a question now about
And well, before we get into the questions, I'm sorry, everybody. Before we get into the questions, and please drop your questions in. But before we get to them, for those of you who've got to go, for CEU reporting, check your email, check your spam. When this session closes out, a survey will pop up. Make sure to take one of those surveys. It's the same survey. Report to GBCI, give us your AIA, and we will report that for you. For those of you watching this on demand, that's the recording, not live. make sure to complete your 10-question quiz with an 80% passing rate. And just a huge thanks to all of our sponsors here, Serve Build Equinox, Smart Ventilation, Sun Intuitive Self-Tinting Glass, Niagara Conservation, lowest flowing toilets on the planet, Panasonic Ventilation for all your bath venting needs, and CERT Air Renew formaldehyde eating drywall. Couldn't do it without our sponsors, without our members, without you, our board of directors, and all of our volunteers. So the question that I have here is, what type of mesh do you use within the render and plaster-based coats with double stud forming system? Can you use, I don't know if this is galvanized or what, but galv with lime?
So typically, we're not using any mesh over the body of the hempcrete. The surface of the hempcrete is just like an ideal binding surface for plaster. So we plaster directly onto the hempcrete, and then, like I said, where the studs show, we typically will use a plastic mesh, but a galvanized would work fine too.
What kind of opportunities do you see for multifamily housing for hempcrete? Primarily, I'm thinking, more stacked, 2, 3, 4 stories. Do you see any opportunities, challenges with that?
I definitely see both opportunities and challenges. I think those kind of either the prefab walls or the prefab blocks would make that really feasible. I think, the drawback right now in multi-residential would be the sort of dry times. On a single family building, you can kind of plot that out and figure it into your schedule. But I think if you, suddenly had a much larger building where that hempcrete was going in over a longer period of time, then you have these sort of staggered dry times that I think, could make scheduling really, really tricky. That said, the prefab walls or the prefab blocks, I think one of the great things about them is, you would be able to make a fire separation wall that's also a sound insulation wall in a really sort of easy one-step process. So, those blocks get a great fire rating and have good thermal value, and so it would allow you to kind of make separations between units that aren't transmitting sound, but are good fire stops.
What do you think for those maybe, and I'm thinking sort of especially urban builders who may be limited on how thick their walls can be, what kind of opportunities or what kind of insulation recommendations do you have for those maybe trying to achieve higher R wall values for passive house or net or zero energy capable? Any insulations to avoid or that you'd recommend for either exterior or interior use?
We work with lots of different things. I'm pretty excited by the sort of the cork panels now, in terms of getting an R value that's up in the range, very similar to foam, sort of like 4 per inch on those. I think straw works really well. We do an awful lot just with typical kind of cellulose insulation. Is a great carbon sequester that's really affordable and has a good R value to it. We've done we've used straw in lots of ways in those scenarios. We've also started working a lot with insulated plasters and renders. Expanded glass aggregate and aerogel type plasters. So it's a lime plaster that we're getting about R4 per inch out of. So there's a huge kind of range of approaches that we use, and they're all kind of always kind of specific to the site and the design and what's available locally.
If somebody wanted to, well, I guess, let's see, I got another question here. Can you speak to what is in the way or what hurdles need to be jumped to get the International Construction Code reports so it can be permitted for the use in the U.S.?
Yeah, I mean, you know, there's two things. One is, you know, getting it passed on an individual basis for, you know, a single project using kind of the alternative compliance pathways that exist in the code. So the handful of houses, you know, hempcrete houses in the U.S. right now, I know of about a dozen, have all sort of gone that route. So provided, you know, European testing and documentation, and sort of argued for the equivalency to what's in the U.S. code, and kind of using the alternative materials pathways there to actually get it, you know, through in terms of widespread adoption. You know, it's obviously it's a longer process. I was part of helping get straw bale and straw clay appendixes into the ICC, and that was about a 10-year process, you know, done on a very low budget by a group of builders. I think hempcrete might jump that way a bit faster because it's more, you know, the block and the precast manufacturers, if they decide to tackle the American market, you know, they would, you know, obviously need to fund that testing and get that material through the code in order for their business model to work. So I know that the Just Biofiber company is doing that in terms of the Canadian codes right now. They're a Canadian company kind of focusing on this market, but you know, that type of work is typically done by somebody who stands to benefit financially from doing it. And so right now it's not clear, you know, who that would be in the American market. So it's pretty much going to be a case-by-case scenario until then.
All right, great, thanks. Well, we are at 1:15. I don't see any other questions. Chris, I really want to thank you for your time. I want to thank the Endeavour Centre. And real quick, I wanted to point out to everybody here this pretty cool project you guys worked on that's not hempcrete, but it's Canada's greenest home, and I hear it's still holding the title. So I think everybody can check that out on your website too if they want to learn some other strategies, especially for the climate zone that you have to deal with. You know, I think only folks like up in Minnesota and maybe northern Michigan have the same issues, perhaps. So it's certainly an accomplishment. So again, where can people find some more information, and if they want to get some training on this, is there any opportunity for that?
Yeah, are you hearing me now?
Chris, yeah, I can hear you. Can you hear me?
Yep. Okay. Sorry. Yeah.
Yes.
So yeah, we do hands-on workshops at Endeavour Centre on hempcrete. The Essential Hempcrete Construction book kind of has everything I know about hempcrete in it, so that's a good way to go. And there are a couple of hempcrete building organizations in the U.S. that people could look up. They also do sort of like on-site training and workshops and things like that.
Okay, great. Well, if everyone has any questions, Chris's contact information is down here at the bottom. This will be available on our website. Everybody have a great week. Take care, and thank you.
Yeah, thanks. I appreciate everybody's time for listening in.